Hi, I welcome you Simscape Introduction section. In this section, we are going to discuss in detail about what is Simscape, what are all the facilities available in the Simscape, what is multi-domain system, how we can implement this multi-domain system with Simscape. Because actually in this entire EV model, we cover all the components to run the simulation. So in that case, if we should know all these features, how we can integrate with MATLAB simulation. And next one, that is code generation topic. So how this can be converted to the hardware preparations. So if any concept, you have to verify with the hardware also. In that case, the same MATLAB solutions can be implemented with the hardware. So in the while developing the hardware, no need to develop any separate application code. So in this simulation itself, we can get a application code. I will tell you one by one. So keep engaged with the entire video. And next one, that is the physical network components. What are all the components? How we can correlate with other domain systems, and how we can model the DC motor with the Simscape. What are all the basic elements are available in the MATLAB simulation. So please keep engaged with the entire video, so you will get to know about those things. And so in the Simscape, there are in the MATLAB Simulink there are two variants. One is called Simulink. This is a basic called block diagram. Already we have discussed this concept. Similarly, in the Simscape, we can develop a schematics. If it is electrical, then we can develop a few electrical schematic. So from that schematic, we can develop a application. And in the Simscape, you have a three different facility. One is called, you can model the components with multi-domain physical system. And similarly, you can get output, and then you can view the we can do the analysis with the output. Similarly, you may get a lot of physical each and every component with multi-variable domains. And you can, if you have developed all the components and then you have verified the results, so you can interact, you can share the output to the real-time world. Similarly, you can take an input from the real-time world, that is called a GPIO or HDMI, something like that. So we can integrate everything with a single platform. And what is a multi-domain system? So the multi-domain system, nothing but in a single application, so you can integrate mechanical concepts, electrical concepts, hydraulic or pneumatic concepts, and thermal concepts. So you can integrate all these four concepts within a single application. So that is the beauty of the MATLAB. So in the other simulation tools, you cannot interface all these components. Either mechanical concepts alone, some software will help you to analyze those concepts. Whereas here, we can integrate all these concepts. If you take a AC application system, that is air conditioning application system, so there mechanical concepts are there, and pneumatic concepts are there, and similarly electrical concepts are there, and thermal concepts are also there. So if you want to design one a perfect AC air cooling system, so the right choice is the MATLAB Simscape. So that's why we took this tool to verify all the problem statements. And what is the features? So features of this Simscape. So you can integrate all the multi-domain systems, and you can integrate, you can develop a separate algorithm to control each and every models. And similarly, you may get a multiple levels of fidelity, like you can analyze the results, and that result may be it will be a very close to the real-time applications. And next one is the optimization tool. See here in this MATLAB, you can write your code as per the C or embedded C domain, as well as that if you have a perfect flowchart, then you can easily integrate that flowchart with the MATLAB simulation. And if you have developed all these things, so you can download the code direct straight away to your hardware. So I will tell you one by one, so keep engaged with this entire video. And Simscape libraries. So in this Simscape libraries, for generally MATLAB, and from the MATLAB you will get a Simulink environment. So in this Simulink environment, you will get a Simscape library. So the first model is that Sim power system libraries and a Sim mechatronics library and Sim hydraulics library and Sim drivelines library and Sim electronics library. So here you may get all these kinds of libraries are available in the MATLAB Simulink. You go to the MATLAB, open the Simulink, create a model. So there you can enter the library browser. Just to open the library browser. Here just to go to the Simscape. Simscape in the foundation library. You may get all these kinds of components. You may get it. So electrical. In this electrical, you can get sensors, sources, and elements. Right. Similarly, hydraulic, magnetic. So you can analyze all these kinds of magnetic issues also, and mechanical. So in the mechanical, translational, rotational elements, mechanisms, and mechanical sources, sensors. So everything you can get it. So similarly, you may get all these domains. You may get a detailed components. And again here in this MATLAB, in this Simulink, you can integrate all these components with one application code. That is the beauty of this Simscape library. And if you take this example, so this example is developed with the MATLAB Sim power system block sets. So each and every component has comes up with blocks. So from this you can integrate the same same equivalent circuit for this block diagram is. So this is the same equivalent circuit. See here, if you develop a Kirchhoff voltage law for this equation, so you can easily understand this concept. See here, V0 is equal to, so this V0 is equal to voltage across this capacitor as well as that voltage across the second capacitor. So if you all these voltages will be equal. Suppose if you develop a KVL. Similarly, for the KCL, current Kirchhoff current law, let us assume that this is the current input. So if it is a current input and this is the current output. So here, suppose if you name it current input current, so IN, and let us take I1 and then I2. So here IL, that is input current, is equal to I1 plus I2. Suppose if you know this equation and then what is the current across through the capacitor 1 and then current through the capacitor 2, then if you have those equations, so from that equation also you can develop this circuit. So that is another method. So while you go in detail, so you may get more accuracy. While you develop any application code, then you may reach exact results. That result will reach the very closest to the real-time experiment, real-time results or ideal results. Now, so this is one case study which is available on the MATLAB Simulink. See here, this is the mechanical component, and these are all the electrical component. So these are all the electrical components, and again here this is called the mechanical component. So here instead of engine you can implement gasoline engine also. So in that case you can implement pneumatic concepts also. Within this single application, you can integrate all these components and then you can take output. So you see here this output. See, let us take the speed is the output. So this output you can integrate with the real-time applications. Like you can connect your any display devices with your computer. So in the display devices, this output can be displayed. Similarly, you can connect input any triggering points to your computer. So that computer will receive a trigger signal from the real-time world, and then based on the trigger signal, then your application code will work, and the same output can be configured to the real-time inverter. So like that you can integrate concept-wise components, that is exact physical components, and then you can integrate the real-time input, and you can take output and then you can show it to the real-time output. So this entire platform with the Simscape will help you to integrate all these components. And what is a code generation tool? The code generation tool, nothing but see here, you have to develop a flowchart and then plant. So the plant, you may be if you are developing an engine with the control valves and everything. So that application code, you can if you have a proper equations, then you can convert it as a proprietary model. So like for example 5 HP motor with electric vehicle applications. So that particular model can be generated as a protected library file. So that library, for that library file, you can develop your application, closed loop control mechanism. So that entire model can be directly downloaded to the hardware. So how the hardware can be integrated? See here, let us take this example. So this is the application code, right? So this is the application code, this is the plant. So this plant is controlled with the help of this application code. So here you can model, you can if you got output with this model with 100%, so you can convert it as a PLL .dll file. So that DLL file will be the protected file. So nobody unless you gave you release the license, then nobody can modify the component, cannot modify the results also. So as per the that particular example, they can give the input and then they can give the out. They can take output from the model. So similarly, you can generate a code. So for this entire block, you can generate a .c file or .hex file or .out file. So based on the hardware output, see, I will tell you one by one. See here, if you, in the real-time world, you need a control signal and then you need a plant equipment. So this equipment is going to control your hardware, right? So if you take this case study, actually, as you know that PFC boost converter we have discussed in the power converter section. So this converter this experiment is giving you the proof of concept. So here we have developed the voltage and then calculated the current inductance value, capacitance value, and then how much load can be implemented and then how much input can be varied, right? And similarly, this is the control algorithm to control your plant. See here, this control signal is going to control this MOSFET controller, right? So if this PWM controls this MOSFET, then we can achieve that desired output. So now the heart of this experiment is the controller part, and this is called a plant model. So this is called plant model. So now this is the controller model and then this is the plant model. So I think now you may understand this concept. So once if you develop, once if you verify the output, all these things, and then based on your concept, if you got the output, then next level is you can change this entire algorithm to the hardware based. How you can move? See here, this is the in the Simulink, in the Simscape block, you can develop a controller like this, and again the same controller can be converted like this. And so if you go into the in detail, if you take a first, you have to choose any one of the controller. So in the real time, you need a computer to calculate your algorithm, right? So in the real time, you have a very basic controller called 8051 or PIC controller or Arduino controller or ARM processors or Raspberry Pi processors, or else DSP, that is a dedicated processors, a DSP or FPGA. So only thing, you have to integrate the block, that is at a particular block to your hardware in your MATLAB software. I will show you how you can integrate those things. Just to open the MATLAB. If you open the MATLAB, if you open add-ons, and first you have to identify your hardware processor. What hardware do you have? Let us take I'm suppose if I am having a DSPIC microchip based DSPIC, so I'm going to take it microchip DSP processor. So in that case, you can integrate this block sets. So if you integrate this block set, then you can able to download this same application code. So you can be able to download this application code to your hardware. So how you can integrate those things? You just go to our YouTube channel. I will share you. Just to go to our YouTube channel and just to search Pantech solutions. Search Pantech solutions. Yes, just to search Pantech solutions. Here you can identify some videos like a PWM, Simulink, DSP integrations. DSP. Here you can get pulse generation for TMS 320F2812 with the MATLAB Simulink block sets. Here so if you go through this link, you can easily understand how the application code can be downloaded to the hardware. So I recommend you all, you please go through this video. I will share this video link in this presentation, so you can easily understand. So like that, you can go through, you can develop your applications. And still this is an application code for the Texas Instruments, that is a TI DSP board. And so actually in my laptop I have installed TI DSP also. Just to search TMS 320F281. Sorry, C2000. Just search C2000 and have an option called Simulink reference application example of TI C2000. So you can integrate this model to your MATLAB Simulink. Similarly, embedded coder support package for Texas Instruments C2000 processor. So this also you can integrate. You can install this tool to your MATLAB. So once if you install, then straight away you can develop your application. You can develop this code to the MATLAB will generate a compatible equivalent code for the processor. So once if it is generated, then we can run our application. So like this. Here in this hardware in loop, here this is the plant model. So this is the load model, and again this plant will receive a power from this input. So this is the real-time input, and for this plant we have to give a control signal, right? So this control signal, this processor will take care about. Actually, this processor is about a DSPIC 30F4011 processor. So from the load, it will receive a signal, and again it will. These are all the input for this plant. So like these input switches. So these switches, via these switches, we can generate an input signal for this plant. So and again here. So the input receipt as well as the output generation. So that is called application code. If you develop your MATLAB in your MATLAB like this application code, you can straight away you can download this code to your hardware. So we are going to verify with this these experiments in the Arduino example. We will check that time also. And if you downloaded this one, then you can successfully you can implement your hardware. So in that case, you no need to worry about the code development for particular dedicated processor like embedded C development. You don't worry about it, right? So this is the advantages of the MATLAB Simulink. And Simscape components. Actually, in our applications, we have to integrate all the multi-domain components. So in this multi-domain components, first you should understand what are the multi-domains, and in that one, what are the basic components. Here in the physical network, if you take these two nodes, P1 and then P2, see here, there are the two major variables. One is called through and across the variables. So through variable, nothing but some quantity can travel from P1 to P2. So that is called through variable. And across the variable, nothing but the difference between, actually P1 is the one node and then P2 is the another node. The difference between these two variables, so these 2 points or these 2 nodes, that is called across the variable. In the there are different type of domains are there. In the electrical domain, we can call it as across variable is called voltage, and then through variable is called current. Similarly, for the hydraulic, flow rate is the through variable, and pressure is the across variable. If pressure is more, then the flow rate also will be increased. So there you can implement some control mechanism to control or to vary the distance. Right? So like this we can understand. So now we should know what is the detailed components to achieve this through and then across variables. See, actually in the MATLAB Simulink, the Simscape, if you take a electrical domain, so the across the through and then across variables are voltage and current. To vary this parameter, you have an option for resistor, inductor, and then capacitor. So by changing the resistor, we can adjust vary the voltage and current. Similarly, by changing the inductance, we can vary this parameter. Likewise, the capacitor. So this is in the electrical domain. Similarly, in the rotational mechanical domain, rotational spring, inertia, and then hydraulic. So these are all the basic components to vary this parameter. And translational mechanical element domain, again the damper and then spring, translational spring, and then MOS. So these are all the components to change the variables. And in hydraulic, similarly in the thermal also. Here now we can understand how the DC motor can be modeled with the MATLAB Simulink. Here the first one is we can use the sim electronics in the DC motor block. Here in this sim electronics, to open the MATLAB and open the library browser. Here in the electrical component, you can get motors. Here the shunt motor, DC motor. If you take this DC motor, again similarly the shunt motor, all the motors are available. Here this is called electromechanical component. Here you can adjust the variable whatever you want you have based on this value. Suppose if you don't know about if you choose this value, rated power and then rated speed, here you can feed the mechanical power whatever you want, and speed of the motor, and then no load speed. Generally the rated speed will be lesser than the no load speed, and input voltage for the particular motor, and then inductance, that is armature inductance. Generally we have to derive these components from the motor the manufacturer data sheet. But if you don't know the value, so better keep very closest value, like a small value of the armature inductance, that is fine. But it should not have a zero value. So very closest value like a 0.01 or a 0.001, whatever it is, you can feed it. Simulation will MATLAB will recognize your applications. And similarly, by developing the equivalent circuit. Here in the DC motor you have a resistance and then inductance, and by developing the equivalent circuit we can model the DC motor also. And next one, that is a custom component. So in the MATLAB Simulink you can develop your own component also. So no need to use this whatever the available in the library. So you can create your own component also to generate a DC motor. So that custom equations can be equation based, that is equivalent circuit based equation, and then composite, like you can integrate with multi variables. So like multi variables nothing but if it is armature or armature resistance, if it is a 0.01 or else 0.001 or else 0.00 So like that you can give a lookup table based equations also. So this is called the electronics pre-built model. So whatever I shown you. And similarly, you can build the equivalent circuit with rotational electromechanical converter. This is the rotational electromechanical converter, and then resistor, and then inductance, and finally you can add these things. If you open the block, open the MATLAB and search demo in the MATLAB, you can get a window. Here you can search DC motor model. Here Simscape model. So here you can integrate, you can get a detailed block diagrams. Yeah. Here I recommend you please go through this equation experiment and get practice it. Just to open the block. Second I will open it. Here you may get an option to open the block also. We see here you can get a open option. Just to open this station and to vary the value. See here in this experiment, this direct DC motor has been used, and other models are all called controllers. Actually, in the DC motor section, we have discussed about DC motor control mechanisms. Like this is a H bridge model. So for this H bridge model, you have to generate, you have to apply a control signal. So that is a PWM control signal. Just to run this simulation, then try to understand this experiment and go through analyze the results. And again, while you change the variables, better change the name and then try to modify it, because these are all the library files which will be available on the MATLAB. Don't disturb that file. So better change the file name and then try to access it. And the next one, that is called, if you know the equation, so you from this equation you can develop your own model also. That is a Simscape DC model, DC motor model. And you can modify the motor. You can modify the motor with your custom ratings also. So instead of these same parameters, see here in this motor, instead of this parameter, if you want to modify this one, then that option also available in the MATLAB Simulink, sorry, Simscape library. So like that, we can model the DC motor on various different manner. So this principle is applicable for all the components. So the only thing we have to know, we have to develop all the equations. Based on that equation, we can develop the application model. So just refer this link, you may get more idea about these concepts, and we will see in the next section. If you are interested in the internship, you will get a certificate by email. For that one, you will get an internship program. So here you can join the VP group, WhatsApp group, and you will get directly, you can get a support from me. How to how to do and how to develop your own vehicle and all. So that is, the cost is only 590. The link is available in the description box, so you can get. And if you are interested, is 11th February 2023. 11th February 2023. Right? So you can join over there. If you have any doubt, you can ask me. I will try to give you the answers. And this is my WhatsApp number, so you can post your queries here also. I will give you. I am here to help you. See here, after joining in the internship, you can directly go to the our LMS website. So here you can get a TV bundle. So see here, you will get a complete classes. So you can download the MATLAB simulations. You can download all the presentations, everything. You can download the PPT, you can download the simulation files, everything. You can get it in the internship. Whereas for the YouTube sessions, you can post your queries. You just follow the live sessions and you can practice on the live only. Yes. So all the sessions are available. If you are interested, you can go and join the internship. You can download it. All the notes are available to download. Thank you, participants. Thanks for valuable time. If you have any questions, you can post me. Just take my number. This is my WhatsApp number. So 98409744408. So if you have any queries about your research activity or your laboratory requirements, you can post your queries here. Thank you, participants. Thanks for a valuable time. Thank you once again.